Okay, so it's on to lesson 5. All right, so we're continuing on dealing with radical equations, um, and radicals and everything related to that, right? So what we are going to do today is we are going to look at situations, equations that have radicals on both sides, and we're also going to look at situations where there are not only radicals on both sides, but there's also other terms involved. So what happens as a result of that is you get some pretty crazy things going on, that if you don't have like a clear cut idea of how to go about it, it can look really confusing. We are going to be dealing a bit with simplifying square roots a little, which is something we haven't done in a while. And there will be some things that we're going to have to try to remember that we may not have covered extensively, and so we'll do our best to make sure that we make it as little confusing as possible. Okay. All right. So hopefully by the time you're done with this lesson, you'll have an idea about how to solve radical equations with radicals on both sides, in different varying situations. All right. So let's get started. Let's look at one. So this is going to be kind of like the generic sort of problem that you'll see for this, where you have radicals on both sides, right? So you've got, let's get this all set up here. You've got a radical here and you've got a radical here. Okay, and we're going to solve this, and then when we're done, we'll check for extraneous solutions, right? So when you have this situation, and basically there's a radical on each side, and there's really nothing else you can do to simplify it, what you got to do then is you just got to say, okay, well, I know how to get rid of a radical on one side. Let's see if when I square it, I'll do it on both sides like you normally would. See what happens. So that's the approach. That's what you do. All right. So when you square this, right, you get 2t minus 7 over here, and then when you square this, you get t plus 2. So this simplifies this into a pretty common type of equation that you guys have worked on many times, right? So now those radicals are gone, and we're in pretty good shape, all right? So remember, what we always want to do is we always want to get variables. So you want to get to a situation where you have variables, right, on one side, and then you got your constants, right, on the other. That's what you want, right? Variables on one side, constants on the other. So let's take the variables, right? We got 2t and t, so let's move t over here. Okay, so we're going to do that by subtracting it. So we'll go minus t, and then we're going to subtract that from this, right? So in keeping with trying to make this as clear as possible, when you do 2 minus 1, right? When you do 2, and I'm gonna erase something here so it's not confusing. I'm gonna erase this line. I was just underlining it so you guys could see it, but I don't want you to think that we're dividing, because we're not dividing. We are, we're adding and subtracting. Remember, that's how you move things around, is through adding and subtracting. So this goes away, right? And then 2 minus, remember, if there's not a number there, it's a 1. 2 minus 1 is 1. So you get t minus 7 is equal to 2. And so then it would make the most sense to move this over here, right? And so now you go plus 7, both sides, and you get t is equal to 9. All right? So this is great. We've got an answer, right? So let's see if it's worthy of being circled. And we are going to do our check steps. So I'm going to do that in a different color. We'll do that in green. Green's a good check step color, I think. So we're going to go square root of 2 times, and now we're going to put in our t, which is 9, all right, minus 7 should be equal to the square root of 9 plus 2. Okay, so let's simplify this a little bit. This becomes 18 minus 7, right? This becomes 11, and then this becomes square root of 11 equals the square root of 11 that is good news. It checks out, right? So if that's the case, then we will decide that, yay, we're happy. Circle that. This works. Okay, so that's kind of the approach. You're actually really not doing anything differently other than the fact that when you do square both sides, what happens is you'll have some other kind of math to do that we haven't had to, moving things around, manipulating variables, all that. So that's sort of how this gets different. All right, so let's take a look at another one. So this one, right, we've got the same kind of setup, right? I could divide by 2, but if I divide by 2, it's just going to move it over here. It's not going to get rid of anything or move it. It's just, so I say in this case, just square them both, okay? Now the thing I want to show you is when you're squaring this, right? When you're squaring this thing, you actually have to apply this to this and to the radical term. All right, it's going to wipe out the radical term, but we also have to apply it to this because it's the same thing as we're applying this, we're squaring this. So if you think about that, that's the same thing as doing this, right? X minus 11 times 2 times x minus 11, right? Where these two are going to multiply by each other, and these two are going to multiply by each other, right? So you're going to get 4, right? So that's what 2 squared is. So when you square this, make sure you remember you have to square that number as well, right? And so when we square the number, what happens is we get 4. And then when we square this, the radical goes away. So we're going to write this instead in parentheses. Okay, and the reason we're writing it is because 4 is now multiplying times this. Okay, so that's kind of a new look. We're not really used to that. So over here, these go away, right? And you get x plus 4. And so now let's simplify with the distributive property over here. So you're going to get 4x minus 44 is equal to x plus 4. All right, and so first things first, let's take our x's and let's subtract x from here. I'm going to subtract x from here. And then in the same step, just to save space, guys, I'm going to switch colors here and we're going to move our 44. Seeing as we're moving our variables over here, let's move our numbers over here. All right, so we're going to do the opposite. We're going to add 44, and then you'll add 44 over here. And so when we do that, right, that's going to cancel out your 44s here. It's going to cancel out your x's here. You're going to get 4 plus 44 is 48 on this side, and this is 3x. Now, all I did is I just combined 2 steps, like on this last one, right? I did this first, got this, and then I got rid of that. So I'm doing the same thing. I'm just putting it in one step. Okay, so you get 3x equals 48. Next step is to divide both sides by 3. Okay, and so now we are going to get, and I'll continue my fence down, we get x is equal to 16. All right, so we are going to put this into our equation, and this is where we are going to run into our first instance of realizing whether or not we understand square roots. All right, so we go 2 times x is 16, so we go 16 minus 11, right? I'm going to put that in parentheses just to show we're adding it in, or putting it in. We're not adding it. All right, over the square root of 16 plus 4. All right, so square root of 16 plus 4 is square root of 20. And square root of 16 minus 11 gives you 5. So you have 2 times the square root of 5 equals square root of 20. And on first examination, you might be like, well, they're not the same thing, so this must be an extraneous solution. But before you do that, remember what you want to do, right, is you want to remember that you can simplify radicals, right, when there's numbers in them. And it has to be in simplest form. And so to do that, you got to go through it and you got to remember all your squared numbers. So I'm going to start from 2, right? So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and then we'll just go up to 6 squared. All right, and so what you want to do before you say this is simplified is, can I divide this by any of these square numbers and get an integer result? Well, you can't divide by 36 because it's too big. Same thing with 25. You can divide by 16, but you're going to get a remainder, right? You're not going to get, it doesn't go in evenly. 9 doesn't go into 20 evenly, but 4 does, right? You can rewrite 20. 20 is equal to 4 times 5. So we're going to leave this 2 times the square root of 5 over here, right? And we're going to rewrite 20 as the square root of 4 times 5. All right, and then remember, when you have that, you just split up the radicals. Square root of 4 times the square root of 5, and then simplify it. Well, the square root of 4 is, is 2. 2 squared is 4, right? So it's 2 times the square root of 5, and then that's where you bring this down and you realize that, hey, they are equal to each other. So this was our check step, right? And it was successful. So this is a valid solution to this problem. And so this is where you're going to kind of need to remember a little bit about what you know when you're checking for your extraneous solutions. It shouldn't get in your way too much with solving it, but you'll definitely need to remember that. All right, we're going to stop the video. Apologize for being a little long, but a lot to go over here.